Hey there, today I'll show you how to create this chrome smoke effect from a Behance project. We'll build the main part in EmberGen and spend a bit of time in Houdini. And we'll finish everything up in Cinema and Redshift. Let's get started. Let's switch to Cinema and set up our collider, which the smoke will interact with. Save all of this as an FBX. You can leave the settings at their defaults. Just save it, that's all. Now let's move over to EmberGen. It greets us with this default setup. We won't change much here, just remove the unnecessary stuff and add our own. By the way, I've disabled all the forces. I added an import node and a collider node, just find them in the search, that's it. In the import node, we simply load our FBX file that we just created. In the collider node, we don't change anything, just connect our import to it and route everything into the collider in the simulation node. Let's move on to the main node. This is the emitter node. Here, our task is to disable everything unnecessary. I turned off fuel and temperature and also set the smoke rate to 100. Yes, I set it to 100. The next tab, pressure, is responsible for pushing out. There we just set everything to 0. There's also a visuals tab. There you can enable or disable our shape, which is actually emitting everything. Let's disable the collider and start the simulation. Great, let's move on to the next important node. This is the simulation node. This is essentially the engine of the entire simulation. Here, you set the size and quality of the simulation. Another very important tab is time control. By default, it's set to 60 FPS, but I set it to 120 to make it slower. The next two tabs are left at their default settings, and we also set the dissipation node to 0. This is responsible for the smoke dissipation. We absolutely don't need this. In the diffusion tab, we also set everything to 0. The vorticity tab controls the swirling of the smoke. We don't need this. We'll create it ourselves using other forces, so we also set everything to 0 here. The force tab. This is also straightforward. Just set everything to 0 and set gravity to 0 as well. Let's go back to the emitter node. Here's an important point. I set two keyframes. We have smoke and at some point it just stops. You can just set the value like I did. Let's run our simulation and see. Smoke appears and nothing happens at all because we don't have any forces. Let's enable our collider. Also, in the visuals tab, you can change the color of our collider. Just to make it more convenient, we'll need forces to somehow affect our smoke. Just use the search to find what we need. I chose noise and force point. It's kind of like a tractor beam in cinema. In the noise node, I set the scale parameter to 10 and the animation speed to 1/10. I've connected all of this to our emitter in the force tab. In the import node, let's just hide our collider for now so we can see the noise more clearly. Yes, the swirling effect is there. Let's move on to the next node. As I mentioned, force point works like an attractor. That is, we have an axis that either repels or attracts depending on what you set there. Let's start the simulation. I've turned off the noise for now. And as you can see, our point is here and from it. So it's being repelled, we've raised our smoke, and now the smoke is going downward. I think it's clear how everything works. Well, the swirling effect is actually interesting. You could even leave it like this, but that's up to you. But I think it will be more interesting with the noise. So, together with the noise, our collider is working quite well, and overall everything looks really good. This is roughly the result I got as well. In the node import under the simulation tab, we can influence the size of our collider, or more precisely its interaction with the smoke. If you need to, you can change this value. We're satisfied with the simulation, so let's move on to exporting everything. The export will automatically generate a name for you here, and it even creates a folder with that name. You can change the folder name as you wish. These are the most important import parameters, first frame and new frame. Here we specify the number of our frames. The first frame is the frame from which the simulation will start, and new frames is how many frames we will generate. This is very important since we only did the smoke. Everything else can basically be turned off. That's why I leave density on and turn off export frame. This is an important point to keep in mind. In EmberGen, axis is not as familiar as in cinema. Here the Z coordinate goes up. We need to change this to Y to make it work properly. Everything was exported and there were no problems with rotation. We go up and click export. Our sequence has been saved. We open Houdini, set the correct frame rate, mine is 30, and I set the range to 100. I added a file node to import our sequence. We add it and simply open it. We move along the timeline to check if everything is working properly. Yes, the animation is there, so we can move on. I add a node before the unpack. Maybe we don't actually need it, but I always add it out of habit. Next step, what we need to do is add something. We have the volume from the render, the attributes are there, and now we'll work with them. We need to take the density and simply multiply it by some value. I've been using 10 for a long time. Let's see how it looks. You see, now our smoke has become denser and we can work with it further. You can choose the values to your liking. The next node is convert VDB. We need to convert it to Houdini's internal VDB format. Set the value as I have it. You can experiment here. It all depends on the result you're aiming for. These values worked for me. Let's move on. There's another way to improve the quality. This is the VDB sample node. We need to change the sample value of our VDB. You can use the same values as I do or experiment as well. Select the VDB Smooth SDF node. You can immediately see that everything has been smoothed down. Here's a comparison. As for the values, it's up to you. If you smooth too much, the necessary swirls won't look as natural. So adjust everything according to your own scene. After smoothing, we can now convert this to a mesh. I added a convert VDB node and set it to polygons. Let's look at the mesh. Yes, we've got polygons, but that's not all. In animation, to avoid any glitches or jittering, we need to set the normals and smooth them out. Add a normal node and I set the values to points so that the normals are on the points. Now we need to smooth these normals. Add an attribute blur node and instead of the P value, instead of the P attribute, we set the N attribute, and now you can adjust the values and smooth everything out. Right now we can look at the before and after. So here they're not smoothed. We added the blur and now everything is smoothed out. Trust me, this is a very necessary thing because in animation everything will jitter and shake. We don't want that. We're almost done with the normals. We need to promote all this from points to vertices so that Cinema understands it and we can continue working with it in Cinema. We click on the last node and see that there's a lot of unnecessary stuff. All of this can be cleaned up so that the Alembic file is a bit smaller. We add a clean node and simply set it up to remove everything except the attributes we need. These are N and P. We export everything to Cinema, add a ROP Alembic output node and set it to render our entire sequence. Since Alembic files can be stored for quite a while, let's just go over our model and check if there are any artifacts. No, it looks like there aren't any. All of this can be exported. In the Alembic node, you need to specify the path. $hip refers to our project folder. We simply enter the name of the folder where everything will be saved and the name of our Alembic file. Click Export. Open Cinema, click File, Merge Object, select Alembic and open it, checking all boxes for animation. We change centimeters to meters for accurate values and proportions, and we see that our simulation aligns properly and integrates with our collider. The simulation is ready. Render everything as the last step. We have created a simulation that is quite good. There are minor reflections on the mesh, but these can be fixed by adjusting the threshold on the voxel size in EmberGen and in Houdini. Thanks for watching. Bye.